Hello, my name is Oliver Manuel. I am an emeritus professor. I have a PhD degree in nuclear chemistry. Following that, I did postdoctoral research on space physics at the University of California, Berkeley. Today I want to tell you why I think the story of Nellie the Neutron and neutron repulsion is important, and why now is the time when that story needs to be told. Popular nuclear physics relies on studies that were done during World War II, when the United States and its allies and Russia and Japan and Germany were racing to harness nuclear energy to make the nuclear weapon that would decide the victor of World War II. In that rush, the essence of nuclear energy was utilized, and the atomic bomb and later the hydrogen bomb were exploded. Nuclear energy was exploited afterwards for in reactors, power reactors. But more recently, beginning in the 1960s, space age measurements were initiated. First, I guess the first major one that everyone knows about is the Apollo mission to the moon, which in 1969. We had a period of, in essence, space age measurements where meteorites were studied, material coming out of the sun, a few pieces of material from other planets have been analyzed. The Galileo mission to the Jupiter was launched in 1989 and arrived there in 1995. The results of all those measurements indicate that the sun's origin, its composition, and its source of energy is somewhat different than what we thought from our understanding of nuclear physics at the end of World War II. So today, what I want to illustrate with a couple of little hand magnets or bar magnets is that the energy from the sun comes from neutron repulsion. So I will demonstrate that with these two simple bar magnets. To keep it so you can understand the different ends of the magnets, I colored the north end of the magnet blue and the south end of the magnet red. Neutrons react toward neutrons the way the north pole of a magnet reacts toward the north pole of a magnet. In the very core of the sun, we have neutrons pushed into very small regions of space, and the neutrons repel each other the way the north ends of these magnets repel each other. So if I try to push this magnet up to that one, you can see the magnet moves away. That's neutron repulsion. This is neutron repulsion. That is the energy source that powers the sun. That's the energy source that causes light to come from the sun. That's why plants grow, and that's the thing that in fact sustains our life, is neutron repulsion. Because of neutron repulsion, the sun also, the core of the sun ejects neutrons, and they go flying off into space. Once the neutrons leave the sun, they don't stay as neutrons. Once they come out of the core, then this is like a neutron that's in the core of the sun, or even a neutron that's in the core of a nucleus here on Earth. When it comes out of the sun, the neutron will decay to make a proton and an electron. So we can illustrate that this way. This is a neutron, it spontaneously decays in about 10 minutes to a hydrogen atom, which is a proton with an electron. Once the neutron comes out of the sun, it makes the neutron decays to a proton with an electron, or this is called a hydrogen atom. Now let me return to the magnets. In the core of the sun, neutrons repel neutrons the way the north end of this magnet repels the north end of the magnet. But once a neutron comes out of the sun, when a neutron comes out of the sun, it ends up making a proton, which is like the south end of a magnet. Then the neutron, although it strongly repels another neutron, the neutron attracts a proton the way the north and the south ends of this magnet attract each other. In conclusion, neutron repulsion is the energy source for the sun. In the story of Nellie the Neutron, we will also show that neutron repulsion powers the universe. Thank you.